Hello and welcome to Homework Help for Lesson 6.8. We will be learning how to change base using the change of base formula, and we'll be doing problems from 1, 2, and 3 in the TAN book. So before we get started, as always, we have some prerequisite skills that we will practice, namely evaluating logs. So let's look at this first example. I'm asked to evaluate log of 100. So whenever we're asked to evaluate logs, we want to find out what it equals. So let's set it equal to x and solve for x. So currently, I'm in log form. To go into exponential form, I'm going to cross out the log, write in the invisible base, that is the base 10, and then basically I'm asking 10 to the which power will give me 100. So just by looking at this, it's clear that x is equal to 2, right? The exponent is 2. And that would be the answer. Log 10 of 100, and you can plug it into a calculator, is going to give you 2. Let's do the second example in the same way. So now I want to evaluate natural log of e to the 5th. So to evaluate log, set it equal to x, and then if we're in log form, we'll go into exponential form. So the missing base here is e. Cross out the log. And the question is, e raised to the which power will give us e to the 5th? Well, clearly again, x has to equal 5. And that's our answer. If you plug it into the calculator, you get the same thing. So before we go on to the third example, let's just look back at the pattern that we're discovering. When the question was log 100, if we are aware that the base is 10 and we see this pattern, the question we can ask ourselves without showing any work at all is basically starting at the base. 10 to the which exponent gives us 100, and the missing exponent is our answer, 2, because 10 to the power of 2 gives us 100. Let's do it again with the natural log question. We had natural log e to the 5th, so the missing base was e. So again, without showing any work, as if you just recognize the pattern of what a logarithm operator does, start at the base and say e to the which power gives me e to the 5. And so the answer, without showing any work, is 5. Let's see if we can do this third example without showing the work, okay? Let's start at the base. So our base here is 2. The question is, 2 to the which exponent gives us 8? If you said x equals, if you said that the answer was 3, then you're correct. So we can simply say, hey, log base 2 of 8 is 3. Okay, if you're feeling comfortable, see if you can do these side problems in under 5 seconds each. Have a go. Okay, so hopefully you paused the video and gave it a shot. Let's try it together. So here, log base 3 of 9. So 3 to which exponent gives us 9? The missing exponent is 2. Next example, 7 to the negative 1 will give me 1 over 7. Answer to the third problem is 0. Can you figure out why? Because 8 to the 0 gives us 1. Anything to the 0 power gives us 1, in fact. And then in the last one, the answer was 3, because our missing base is e. So e cubed gives us e to the third power. Okay, anyway, that's just a quick recap on how to evaluate logs. Let's look at the next 3 problems, though, and see why they're different. Okay, so in log of 20, we'll write in the missing base 10, and we'll ask ourselves, 10 to the which power gives us 20? So you'll quickly recognize that actually there is no exponent. We can't come up with it from the top of our head. If you said it was 2, then I need you to check your work, because 10 squared is not 20. That's 10 times 10, which is 100. So we don't actually know this one off the top of our head. We have to use a calculator. That's what makes these problems different. We've got to use a calculator. So let's pull up a calculator really quick and do this together. So the way I like to do it is just Google scientific calculator. And then let's do log It opens some parentheses for us, 20. And then you're going to close the parentheses, hit equals. Our answer is a weird decimal. Log 20 equals 1.3010. I like to round to 4 decimal places. And so should you. Okay, let's try the next example. ln of 3.6. So again, our missing base is e, but we don't actually know how to answer this question. We don't know the missing exponent. So we've got to use a calculator again. Well, luckily, our calculators have an ln button. So hit natural log, and then 3.6, close the parentheses, and our answer is 1 point. Let's write it in. It's equal to 1.2809. Sweet. So when we can't think of the exponent off the top of our head, it's not something easily that we can easily calculate, we'll use our calculator. Okay, let's do our third example. Log base 2 of 7. So, why is this problem different from both of the last problems? Well, if we try to think about it, 2 to the which power gives us 7, you'll quickly get stuck. There is no exponent. 2 squared gives us 4, and then 2 cubed gives us 8, so we've skipped over 7. So we got to use our calculator. However, there is no calculator button for log base 2. There's no button on the calculator that can do log base 2 for us. Look again over here on the right. We have a log button, which assumes base 10. Separately, we have an ln button, which assumes a base e. So in order to do a problem like this, log base 2 of 7, we have to use something called the change of base formula. Since our calculator can't do log base 2, we have to change the base so that we can use either the ln button or the log button, the only log buttons our calculator has. Hence, we'll learn this formula in class. So here's how the change of base formula works. If you have log with some base, let's call it b, of some number, let's call it t, then that equals to log of t, so the big number goes on top, t stands for top, and then the base, or you can think of it as bottom, the base goes to the bottom. So looking at our previous problem where we had log base 2 of 7, we would rewrite that using the change of base formula as log of, which one goes on top again? The big number or the base? The big number. So log of 7, and then divided by, remember, base to the bottom. B stands for base. B also stands for bottom. You can't mess that one up. So log of 2 down in the denominator. So let's see how the calculator will interpret this. Notice that now that we've changed our bases to just a log, we can use the log button. Let me clear. So we're going to do log 7. Now this is really important. You can't just press the division sign. Okay, you have to close the parentheses first and then write divided by log 2. Close parentheses again, hit equals. Hey, and we got an answer. 2.8074. We got to round up because that fifth decimal. So let me write it in. Equaled 2.807, and instead of writing 3.5, I'm just going to write 4. I'm going to round it up. And that's it. That's how the change of base formula works. So as long as you remember, the big number goes on top, the base goes to the bottom, and basically you're doing a division problem. Let's look at problem number 1. C. Okay, it says log base 5 of 60. So you can try doing it in your head first. Okay, our base of 5. So 5 to the which exponent will give us 60? Well, there isn't a nice round number that will give us for our exponent. So we're going to use our change of base formula here. That's the same as log 60 divided by log 5. Okay, let's go use our calculator on the right side. And I want you to try it yourself. Don't just copy down what I'm doing. Try it yourself because on a test, you want to make sure you're using your calculator properly. You're not discovering, oh no, I was doing it wrong the whole time. This is the time to find out. So try it yourself. Log 60 divided by log 5 and see what you get. So I got 2.54395. So I'm going to make that 5 is going to round this up to a 10, which makes this a 4. My final answer is 2.5440. Check your work. If you got an incorrect answer, this is likely what happened. You probably wrote log, open parentheses, 60, and then you hit division before closing the parentheses. So you need to go back, make sure you close those parentheses. Okay, let's do problem 1D now. Log base 4 of 22. So again, 4 to which exponent gives us 22? Nothing that I can think of, right? If the problem had been log base 4 16, we could actually very easily figure out that the answer is 2, because 4 squared gives us 16. Or if it was log base 4 of 1, 4 to the which power gives us 1, the answer would be 0. But log base 4 of 22 is tough, so we need the change of base formula. So which one goes in my numerator? If you said 22, you'd be correct. So log 22 divided by log 4. Let's go to our calculator. Okay, practice typing it in yourself. Notice how I'm closing the parentheses after every log. Divided by log 4 equals, and I got 2.2297. All right, we're moving on to problem number 2 now. So, problem number 2 is we're solving exponential equations now. 8 to the which power gives us 50. So, again, an exponent that we can't think of from the top of our head. So in this time, we're going to go from exponential form into log form. Let's do it. Bring down the exponent first. X equals, and then write down the word log. What's our base here? Our base is 8 of 50. Hey, this is another part where we have to use the change of base formula. Log base 8 of 50 is not something we can type into our calculator. Again, our calculator only does log with base 10 or natural log with a base e. So our next step is to apply the change of base formula. Log base 8 of 50 is the same as log 50 divided by log 8. Let's put that into our calculator and get our final answer. Try it yourself and see if your answer matches mine. I got 1.8813. So that's what x equals. Let's go to letter F. I have 5 to the 4x equals 120. So we are in exponential form. To solve this, we'll go into log form. Let's do it. Bring down the exponent first. Write down the word log, and then what's our base here? Our base is 5 of 120. Okay, so before I go and divide both sides by 4, I know I'm eventually going to have to do that, right, to get x by itself. But before I do so, I want to actually evaluate what log base 5 of 120 is. So I'm going to do that right now. Okay, so we're going to find log base 5 of 120. So if you go into your calculator, write log 120, please be aware it's giving you an answer with a base. If you type this in, it's giving you an answer with base 10, which is incorrect. So you have to use the change of base formula so that you stay true to the base 5 that we have. So we got 4x equals, change of base formula is going to be log 120 divided by log 5, and now we can put that in the calculator. Log 120, close parentheses, divided by log 5, close parentheses, is equal to 2.9746. So 4x equals 2.9746, and now in the final step, to solve for x, I'll divide both sides by 4. So using my calculator again, just divide it by 4, and I will get x equals 0.743